My name is Logan Harris. I work with Brandon Kaiser, Garrett Kane, and Jackson Munster Tiger. So for this problem for solving for the electric field, there was kind of two separate approaches that I thought of. You could either do an integral to solve for the charge along the path, and then you could integrate that along the electric field, or to find the electric field. And I was more comfortable with the approximation approach, so I went with that. I decided that if you were to square off the corners of the dish, it would look like a ring. So that's what I did, and I took 10 sections. So to get those 10 sections, I took the height, divided it by 10, and then took each of those values and plugged them into the path equation to get a radius, x. Once I got that radius x, I could solve for the surface area of the ring, and I'm assuming that that's rectangular with a height and then a diameter. So to get the area of that, it's circumference, or it'd be circumference times height, and my height was 0.0025 meters. So that gave me an area, and then I could use that area times the charge density to give me a charge of each ring. Each one of those charges is different, and then I took that charge and I used that in the electric field of a ring equation, and then the other variables obviously too, and then that gave me the electric field of each ring. Once I got the electric field of each ring, I could add them up, and then I got the net electric field. For the voltage, I assumed that though you didn't have a charge, so the electric field was just the net electric field, and then I used the equation delta V equals negative E delta S, and then delta S was just 3 meters. So your voltage was, I got around 27,000. And then for the voltage that could cause arcing, I found, we didn't learn about that in class, I don't remember, but I used Poisson's law, and it said that you need about 3.4 million volts at a meter to arc, and since I only had 27,000 and I was at 3 meters, it wouldn't arc. And then I'm not sure exactly how that equation works, but at the volts that I'm getting, as delta S gets smaller, my volts are going to get smaller too, so I'm assuming that it won't arc even if I get close to it, like when you're cleaning it. I'm assuming it's not going to arc.